Alright guys, today in physics we're going to unravel the triangle. Okay, some of you have been out of geometry for a while, so we want to make sure we take our time with this and make sure we remember where we're going. Some of you are already in pre-calc, but you're not going to cover this stuff till later. So let's make sure we remember SO, CA, TOA. Okay, the SO part is our sine is opposite over hypotenuse. I know that's terrible writing, but that's what it is. It's going to look like that. So sine is opposite over hypotenuse. So if I have an opposite and I have a hypotenuse side, I'm going to use sine. Okay? Cosine is adjacent over hypotenuse. Okay, so this is cosine. We have adjacent and we have hypotenuse. We'll work at those. We'll look at them. We'll see what's going on with them. And then TOA is tangent is opposite over adjacent. Okay? And yeah, hopefully these are things that you still remember. If you don't though, make sure you get that written down. Make sure you remember it, because this is something you're going to see a lot. Okay, so let's go ahead and let's draw a triangle. I'm going to leave that up there so you kind of have reference to it. Alright, so here's our first triangle. Okay, so all we're going to be dealing with right now is right triangles. And I'll show you how to make any triangle that you want, or anything that we're going to have vector-wise into a right triangle. Okay, so let's say that we know this angle, and let's call it angle, let's call it 38 degrees. Okay, so if this is a 38 degree triangle, this is the angle here, and it's a 90-degree triangle. Okay, we should know the other side. And it's going to be the complementary angle to this one. So we're at 52. That's 52 plus 38 is going to give us 90. Okay? Now, if I know one of these other sides, okay, so let's say I know the opposite side. Okay, so if I'm at 38, my opposite side is the one away from it. So this one is going to be, let's say it's got 5 meters. Now, later on when we start doing vectors and we start covering some other things, this may not be just like a distance. This may be another unit. This may be meters per second. It may be an acceleration. There's several different things we can do with that. So don't freak out when we start drawing vectors, start drawing triangles with things other than lengths. Okay, so if this is 5 meters, I can solve for my hypotenuse, or I could solve for my adjacent side. Okay, so let's go ahead and solve for our adjacent side, or at least plug it into our equation so we know how to solve for it. So if I wanted to solve for the adjacent side, here's what it would look like. Okay, what side do I know? I know the opposite side. So let's go up to the top. Okay, which ones have opposite in them? Okay, so has opposite in it, but the angle that, or the side that's left out for here is the hypotenuse. So I don't have the hypotenuse, but if I wanted to solve for the hypotenuse, I could. The one that has the adjacent is TOA, so tangent. So let's go ahead and write tangent equals opposite over adjacent. Okay, so let's start plugging stuff in now. Okay, so it's tangent of theta. I guess I didn't write that in there. That's tangent of theta, because theta is our unknown angle. So tangent of theta, or excuse me, in this case, we know it. So tangent of 38, because we said before we were working from the 38 side. I could use the 52 and we could solve for it as well. But now it's the opposite side. There you go. Okay, so there's lots of ways to solve triangles if we have multiple angles, if we have multiple sides. So tangent of 38 equals opposite, and we said the opposite is 5, over adjacent. That's the worst adjacent ever, but that's okay. So here's our adjacent. It's down at the bottom. We're going to just rearrange this equation so we can solve for it. Okay, so what that's going to look like is we're going to leave the 5 alone. So it's 5 meters over, am I still on board? Good. Over tangent of theta, or tangent of 38, equals our adjacent side. Okay. At this point, I sure hope you can find the tangent button on your calculator. I sure hope you can find the sine button and the cosine. Okay, so this one, not too bad. Okay, so if we're solving for a side, they're pretty easy. We will work lots of these, so I'll show you that here in a little bit, or tomorrow. Sometime in class, you'll see lots of triangles. Okay, so let's do, instead, let's see if we have to solve for an angle. So let's say we have a very similar triangle, and this is our theta. Still a right triangle, because that's all we're going to be working with is right triangles. And let's say this side is 10 meters. Okay, so we know this side, we know that this is theta. Now, we probably need a little bit more information. Let's go ahead and let's give two different sides here. Let's give that this side right here is 12 meters. Okay, so I have a 12 meter side, I have a 10 meter side. What's my angle right here? Okay, so we're going to plug it in. We're still going to go back to, let's not use that one. I know you're going to be mad at me, but that's okay. Let's say that the hypotenuse is 15 meters. Okay, so let's use one of the different things up here. Let's use one of the different items. So I know the opposite side and I know the hypotenuse. Okay, the one that has the opposite side and the hypotenuse is sine. So our equation is going to look like sine theta equals opposite over hypotenuse, or sine theta equals 10 over 15. Okay, here's where people start getting mad because their calculator starts doing weird things. You start getting calculator errors. Because you do the 10 over 15, which gives you 0.67, and then you have sine theta. And so you try to then divide by sine, and it doesn't work. Okay, remember, you can't divide by sine, but you do have the handy-dandy button on your calculator, the second sine button, also known as the inverse sine, or the arc sine. However, Mr. Wasson talks about it in class. But I call it the inverse sine. And so what that does is you're essentially multiplying by the inverse of sine. So it's sine, it's got the little -1 up top. And you're going to multiply that by 0.67. We're going to take that function of that, okay, and that will give you theta. Okay, so we'll work through those problems. I really want you to kind of get answers on those last two problems we just did. That way we can take a look at them in class and we can see if we're right, see if we're wrong, see if we're missing things, just oddball. Okay, what I want to show you right now is how we're going to make right triangles out of just about anything. Okay, there's going to be times where we have somebody going off in one direction and they change directions and they change directions again, so you end up with some weird stuff. So let's say somebody went on a hike, they have a vector direction going this way, then they head this direction, and then they come back. Okay, our goal out of these things is to come up with right triangles. Okay, because we want to figure out ultimately, and we'll talk about this more when we talk about vectors more and more and more, is essentially our displacement is right there. So at the end of the day, we've walked a lot, but we've only gone that far. That far. Okay. So in order to figure out how we do this, we're going to break down these individual lines. Because some of you are going to try to come up with some sort of weird triangle. You're going to try to figure out, you're going to connect this and then try to figure out where we're at. What I want you to do is I want you to think a little bit different. Okay, we're going to break down, we're going to go one vector at a time. So if I were to draw this line right here, how would you make it a right triangle? Okay. All you're going to do is you're going to set a horizon. If I set a horizon there, how do I make it a right triangle? I'm going to drop perpendicular to my horizon. Ta, ta. Right triangle. Okay, pretty easy. Okay, let's do the next line that I drew. Okay, I drew one up going this way. Okay? I'm not going to start from my bottom horizon. I'm going to start from where I started on that particular arrow. And I'm going to draw another horizon. Why am I doing this? Because I can. Okay? It's okay. We can draw horizons. We can move our coordinate system, our coordinate plane, wherever we want. We just adjust. Okay? And I draw it straight down. Guess what? I've got another right triangle. Okay? Right triangles are easy to work with. Okay? And let's do our last one. Our last one started up here and then went down. And how am I going to make that a right triangle? A couple different ways. I could draw it from here. I could do a horizon up there. Or I could do a horizon down underneath. Either way, we'll get it done. Okay, so if I start at the top of it, though, and work my way across, it's not going to quite work the way I want it to, I guess. I'm going to have to draw a vertical horizon. Not a vertical horizon, that's kind of weird. I want to draw a vertical line. Okay, and then I can draw it directly to my y-axis. And once again, now I've got a right triangle. Okay, so right triangles, making them is pretty easy. We're going to be making lots of triangles the next probably week and a half, 2 weeks. So make sure you know SOHCAHTOA. Make sure you can do those things. Work those problems that we did before. I'm going to ask you the question if you've done them. I'm going to see if you got the right answer. All right. Hopefully we'll have a great day tomorrow. Tomorrow looks like we have WebAssign. Hopefully WebAssign's up and running. So we'll see you tomorrow. Have a great day.